up.
We're going to be moving pretty fast, so grab me, wave me down if I'm like whizzing past everybody, because we're going to be covering a lot of stuff. Did you start already? All right, welcome to web design class. This is going to be 6 weeks, 2 hours a week, Friday nights. So we got 12 hours total. We're going to be targeting roughly the equivalent of a freshman year HTML class in college, which is typically 36 hours. So we're condensing each hour of college class to 20 minutes. That means it's going to go fast. Okay, before we get too in-depth in everything, the papers that you have some information about homework this week for people who want to keep up, and information about reading this week for people who want to reinforce. All the materials that we're going to be going over here, including the slideshow, hopefully the video, but don't count on that. That will take some doing to get ready. And all the samples that we're going to look at today are all available on the school network. So you can go onto the computer and you can see those samples in your own time. And see Mrs. Burdick, she will help you with that because she knows how to do it. But the instructions are on your paper as well. But I can get to that this week. You don't have to feel the need to get a hold of us. And at the beginning of the slide show is my email. So if anybody has questions during the week, you can email me, ask questions or whatever. All right. Website design is about standards. Why standards? What's important about standards? Everything on the internet is about standards. The whole purpose of the internet is interoperability. You want to be able to share information with other people. You want to share it across platforms. You want to share it on the other side of the world. If you made the internet so that people couldn't interoperate, it would be a really limited platform where, yeah, you could talk to your friends who all pre-arranged ahead of time how you're going to talk to each other, but you couldn't talk to people you didn't know. You couldn't share information with all kinds of people because you weren't using standards. So what do we mean by standards? Standards across different platforms, other than traditional computer technology, there's some really key areas that have real important standards. Things like the highway. We drive on the right. The signs mean a certain thing. We turn on red. We stop at stop signs. These things are really important. If you drove under one set of standards and other people drove under other set of standards, you'd have head-on collisions all the time. If your languages were different, we couldn't talk to each other. No one would be able to communicate. And we see that, if you travel to another country, we have standards within our countries, but often we don't have them between countries, and we have a breakdown of communication. So you can see where it doesn't work. Telephones, obviously the telephone system, everybody's phones work on the same system. Passports in all kinds of different countries, you're able to keep using these things. The really, really prevalent standard that's incredibly important is railroads. They started building railroads in the 1800s in New York City, and they decided on 6-foot wide rails, and California started building one heading east with 5-foot wide rails. We'd have this problem. They could meet in the middle, but they'd still have to move everything from one train to another because they couldn't use the same tracks. So standards are really important in these industries. So in computer technology, in the internet, we're going to be looking at standards in the same way. This is a technology that's designed for people to be able to use all this stuff everywhere. That's why we're using it. That's why web pages are cool, because any web page that you can see, anybody can see. So we want to. This class is really going to be geared around the standards of making web pages, because there's lots of other ways to make web pages, and actually I was just discussing this with Mrs. Burdick, that there are a lot of places that don't use standards, and you end up with problems that only a certain group of people can see your web page. Only a certain group of people can see all of it, see the way you meant it to be seen, get the content off of it. We've got 6 days. This is kind of our outline. Today we're going to be covering the basics of XHTML. Next week we're going to be going on to more XHTML. We're going to be doing 3 weeks of CSS, and then we're going to be covering all the miscellaneous topics that we can kind of throw together the last day. Real quick, I just want to talk about some resources, so when you have questions that you can get to things. There is, for web design, there's an unbelievable amount of content available to help you. If you go to a bookstore, you're going to find more books on web design, on HTML, than any other subject. It's unbelievably prolific. And if you go on the internet, for obvious reasons, the internet has more information on web design than any other topic. There's a tremendous amount of stuff you can get to. So this is the website of the World Wide Web Consortium. The thing that makes this group important is they define the web standards. It is run by Tim Berners-Lee, who's the guy who invented or created HTML in 1990. He started this organization to provide standards so that people could keep communicating using the web. It's a pretty technical site, but it has a lot of information. If you ever have a question about things, this is where you can turn. They have all the core information on web design and web technologies. This website is really awesome. They are a private company that makes training materials for online web design classes, and they cover a lot of technical subjects. They're incredibly accurate. The amount of material they have is really amazing. It's completely free to use. They do offer some paid services like certifications and stuff, but for the most part they have really awesome tutorials, glossaries, indexes. It's a really good place to turn. I turn to it all the time if I just want to look something up. They have the best references. Another good one, webdesign.about.com. About is a general educational resource. Their web design materials are pretty decent. Number of books, I just want to run through these real quick so you know what you can turn to. This book is particularly good, and I have it here for anyone who might be interested, and the teachers are the ones that might really be interested in this. We're going to be looking at this book, it's the same one that's up there, for the lower grades, potentially for projects. This is a visual, quick project guide. It's written by the same author that's doing the textbook for this class, Elizabeth Castro. She's the top-selling author on web design. It's a real short book, and the whole thing is geared around one particular website and how to make it as a project. So it's really good for beginners who aren't looking for a whole bunch of in-depth information. It's really easy to go through, full of pictures, and so it would be really nice for lower grades to use. This book, which I also have up here, if people want to see these, this is the Elizabeth Castro book. This is the main one. It's the 5th edition. It's pretty big. It's really cheap, which is nice. It's $22. Most books about this size for web design, you're looking at $30 to $60. It's got a lot of material. I'm going to be following a lot of this for this course. It does have a student edition. It's more expensive, and I don't know what extra it has because they don't normally sell that in the stores, but if you go on like Amazon, you can get it. Just to give you an idea, this is a follow-up book to the one we're using. This carries right on after the last book I showed you. If you like the material you got in that, you didn't want to wait for us to have a course on it, you can go right into this book. It's really nice. Same format, so if you like the format, that's really good. And this is the 3rd one in the series, so you can just keep building on the same series of books. This is a pretty low cost. I don't know the cost of this one, the list price, but it's a real small pocket book. It's really nice as a reference. You can almost fit it in a pocket. And all of these are really easy to find. Borders, Barnes & Nobles, Amazon, they're almost always on the shelves. This one is really cool because it's under $3. And we have this one here. The school has 3 of these. We're going to try to get more. If a lot of people in this class are interested, they're not the best books, but they're under $3. If we can get enough together, we can place an order from Barnes & Noble, which is the only place that carries them because they publish them themselves. And we can get 10% discount and free shipping, so it'd be like $2.69 total. I think we need about 14 people to get them. But it's a pretty nice book. It's easy to read. The format is a little bit weird. It jumps around quite a bit. Probably not as much as I do, but okay, that's it. Those are the books. Those are the websites. If you have questions, ask me. But they're really good places to turn. All these books are really beginner. If you want to go into advanced stuff, this series goes into a little bit of advanced. There's some actual other books that are the quick pro guides. They're pretty good. They continue that on. But switching to New Rider Press, they have a tremendous amount of really good advanced material. But you start getting a lot more expensive, and you really want to have this stuff mastered before you start playing with that. All right. For those who've never actually had to tackle this question, what is the internet? And because we're going to be dealing with standards, because we're going to be dealing with the core technologies and why websites work, I want to get this covered. The internet is, I actually looked up this definition, a worldwide network consisting of millions of individual computers and networks connected together through the use of a standardized communication protocol called the Internet Protocol, or IP, as most people refer to it. Hence the name the Internet, because it runs on Internet Protocol. We don't need to know why the Internet works. The thing that makes it important is that there's a standard called Internet Protocol, And all the internet is, a lot of people think that there's big servers, there's all this stuff going on. There isn't. The internet is really tons and tons of people connecting with computers in their home, computers in their business, to identical networks, and it's just one humongous network where everybody can talk to anybody at any time. And because of the standards, you can talk to any computer on the internet at any time because you're all talking the same language. So what is the web? Quite often, we refer to the web and the internet as the same thing, but they're not. The internet is a really core technology. Internet protocol. Computers talk to each other. There's no details. There's no specific applications. It's just this really general way of potentially talking to people, but without language. The internet would almost be analogous to people talking with their voices. Everyone's voices are about the same, and everyone's ears are geared to hear those voices. But that's it. When you want to get beyond that, you need a language so you can actually have some information. And the web is really a collection of those languages that work together. The web is kind of a loose definition, but it is a group of protocols that run over the internet protocol to deliver content. What does that mean? We have hypertext protocol, the file transfer protocol, and Gopher. Gopher really doesn't exist today, so we don't need to worry about it. It's part of the definition, but nobody has seen it since 1995. FTP and HTTP are the big ones. HTTP being the one that people normally think of with the web, and it's simply a transfer protocol for getting files from one machine to another. You don't need to know the details of it, but that's what defines the web. It's the group of internet-connected machines that are using HTTP to move files between each other, or FTP, but generally that's used for corporate work or large application downloads. You can use, a lot of people will refer to web technologies not on the internet but inside private companies, and they're using the same technologies, they're just not connecting them to the internet. And the last thing of purely technical that I want to cover is, what is a domain? A domain refers to the network naming. Everyone familiar with yahoo.com? Yahoo, the company, owns the domain yahoo.com. .com is not the domain, yahoo.com is. But you go to, quite often, you're going to go to their website, you go to www.yahoo.com. The yahoo.com is the domain. They own anything.yahoo.com. www is the name of one of their hosts, a single machine sitting behind in that domain. Mail.niagara.com, that's our server. Mail.yahoo.com is another one of their servers. Messenger.yahoo.com goes to another server. Each one of those is its own identity, and those names refer to specific machines. So when you're going to be doing your own website, if you're going to be dealing with actually putting it up so people can get to it, you need to think about having a domain. And to get a domain, you have to purchase that name from ICANN. They're a regulation body who owns all the internet names. And you can go out, you can get myfirstpage.com, and you have the right to host anything at that. www. You can have computer number 5 at that domain name. And the thing that makes the domain names important is, without them, you can operate a website without them. You don't actually, there's no rule saying you have to own one. No one can find you. Without the domain name, nobody knows how to reference you when you're on the internet. So it's really important in making the internet usable to people. Without it, it's very difficult. You'd have to know the actual address of a computer, which is a number. You might have to go to 24.68.122.12. Well, that's really annoying to remember. People aren't going to remember that. They need to know, oh, wait, www.yahoo.com. Well, that's easy. So that's why domain names are important. The Uniform Resource Locator, the URL, is everybody familiar with URLs? Okay. You use them all the time, you just may not know what they're called. The URL is our way of referring to a resource on the web. And this is what you type into the address bar of your browser. If you're going on Internet Explorer, if you're going on Netscape, you type in http:// whatever. That whole thing is your URL. And knowing how this works is kind of important. I'm hoping this diagram comes through. Oh, it did, actually. It's a little bit hard to read. I didn't make up this diagram. I got this from somewhere. I'm going to have to make one up myself that's a little bit more readable. How well can people see this?
Can't see the blue one or the green. The other.
Okay. Can you see this part? Because I'm going to read the rest of it to you. Okay, what this says is http://www.samvid.com/i101/internet101/web.html. And what this points to is the first part of your URL is the protocol. And it's just telling the system that you're going to use HTTP, you're going to use FTP, and long ago you're going to use Gopher. You just let it know how you're going to communicate. Then the second part, the www2 in this case, is referring to what specific machine you're going to. The famvid.com, that's the domain that we talked about, so you know where you're going. And then everything past that is just folders and files on that server. And so the URL is just a way to refer to a very specific file on a computer, but it has all that information in one place. And this is something that you're probably going to want to sit down and just look in the book or look at this diagram when you can actually see it, and it's something you use all the time. You'll understand it as soon as you see it. Okay. How does the web work? What is a web server? What is a web browser? What are we talking about? The web is based on client-server architecture. Your computers are clients. When you go to a web page, that's a server. You have a transaction. The server has web pages on it, and it gives it out to the client, which is you. And you consume web pages. It's called consuming a web page. And we have a cool picture. The server is much like a server at a restaurant. This is to keep me from getting way too technical. We have a picture of an actual waiter. The server comes out, brings a menu. This is what we're offering. What would you like? And you can imagine the menu being full of URLs. Oh, what URL would I like to go to? The client looks through the menu, says, oh, this URL. Can I have this one? The server says, sure. The server goes back to the kitchen, gets what the client wants, comes back out with that web page and a glass of water, and brings that to the customer, and the customer consumes the meal. Luckily, consumes works in both cases. So that's really how it works. So when you're thinking of web pages, think of there is a server somewhere. There's a machine that's job is to get what you want. That's what it does. And your machine's job is to ask for the thing that you wanted and present it to you. Okay, there's more than one type of web client, but the one we're used to is the browser. And so it's the only one we're going to be talking about. By far, most people use browsers when they're working on the web. There are tons of new ways, especially today. We're constantly coming up with new ways to interact with the web without using browsers. There's really cool stuff that's happening in the web service space. They've got regular applications that you can use on your desktop. You don't feel like you're on the web. You're using a regular desktop application, K-Office that everybody's used to. You're working with something that looks just like that, but the data that you're working with is actually interacting with a server somewhere. It's all transparent to you. You can't even tell. Web services is letting that happen. It's really cool. The web has been around since 1990, but the internet's been around since 1969. To give you an idea of how the age difference between the two. We use the internet for things like email and remote server management and research for 21 years before we came up with the idea of using web pages on it. So this is actually relatively new. People are still coming up with ways to use the web. When we're looking at browsers, which are the big way of consuming things on the web, there are four main families of browsers. There's not just one. Obviously, different companies make these, individuals make these. But luckily, we're limited to four that represent more than 99% of everything on the web, everything being used on the web. Internet Explorer, I'm sure everyone's familiar with Internet Explorer. Internet Explorer is currently the dominant browser. It is losing ground rapidly at this point. It sprung up out of nowhere, overtook Netscape, and then is dying away quite quickly at this point. It's available on both Windows and Mac, and it has a whole bunch of proprietary extensions, which means it's really good, when you give it standards, but you can give it to a lot of stuff that aren't standards, and it will act like you gave it standards and not complain to you. So it's really good at convincing people to use it. It's one of its strengths. Gecko. No one's heard of Gecko because they never call it that, but that's its actual name. Gecko is the technology behind Mozilla, Firefox, Netscape. I'm sure everybody's heard of Netscape. Netscape doesn't make a browser. Netscape goes to Mozilla, who makes Gecko, and they get Gecko from them. They slap Netscape on it. That's the Netscape browser. The big one of the Gecko family is Firefox. Firefox represents 8% of all browsers on the market today, and it grows at 1 to 2% a month. They're really up and coming. It's really nice, really good standards. Works well. It's free. Go download it. And Mozilla owns Firefox. They make that. So, KHTML. This is another one that no one ever hears the name of. It's the technology behind a couple browsers. The really big ones being Conqueror, which is what's on all the machines here. If you look down at the bottom in your taskbar, you've got the little planet with a gear halfway around. That's Conqueror. That is the web browser on these machines. And KHTML is the engine behind it that does all the work. In Safari, for anyone who uses Macintosh, since 10.0 or 10.1, Safari is the browser on Macs. That is also KHTML. It's exactly the same as the one here. Opera is the only browser you have to buy of any major browser. It's made in Sweden. It's a really nice product. It's super fast. And they're about 1% of the market. But they're a pretty big player. They do a really good job. When we're talking about web pages, there's a number of things we can refer to. There's not a single thing called a web page. This makes it kind of difficult to talk about web design. There's a group of documents that are textual. HTML, everyone's heard of HTML, I'm sure. Is there anyone who hasn't heard of HTML? Good. Okay. HTML is kind of the granddaddy of web technologies. It was developed in 1990. It is what was used for years to make all those really ugly web pages, flashing links, white backgrounds, did nothing. That was HTML. XML is a new technology used for all kinds of things that we're not going to go into. XHTML and CSS are the current dominant technologies. These are the ones that replaced HTML. WML is used for cell phones. You can use Flash, which I'm sure a lot of people have seen. You can use plain text on the web. There's no reason you have to use something like HTML. Technically, a web page can be nothing more than a page of text. It's not interesting. There's no reason to do that because you can do cool things with HTML or XHTML, but having a text page on the web does qualify as a web page. You can have images, audio, video, all kinds of things on the web. But they're not really web pages. You should start getting more away from the web page idea that's just content that you're downloading. The purpose of this class obviously is to do web design for browsers. This is what people think of when you say web design. This is what they're intending to do. 99% of the web is making pages for browsers. Like I said, HTML was the original standard. It was really popular. 1990 to 1999, it was the technology for making web pages. Around 1997, the World Wide Web Consortium, the W3C, decided that HTML was not going to cut it long term, and they had to do something because it was really difficult to work with. It was really sloppy. You could do almost anything with HTML, and it would probably turn out something, but almost never what you intended, and definitely not everywhere, just some places. And it was really tough to maintain. It made working with the web really difficult. So in 1999, they proposed a new standard called XHTML to replace HTML. XHTML was ratified in January of 2000, and for the last 5.5 years, XHTML has been the only accepted standard on the internet. HTML has been deprecated. Today, most colleges still teach HTML as if it's an acceptable language. It is not. There's no case where you should be using it. It is problematic, and with the focus of web pages being to make there's never a case where you want to make a web page that most people can't see, or many people can't see. The purpose of making web pages, whether it's your personal blog of, oh, this is what I did today, I ate this for breakfast, I hope that I get to have a good day at school today. You can have all that, But why would you put it on the web if you didn't want lots of people to at least be able to read it if they wanted to? You don't want to have people show up and go, that didn't work. So HTML, is the reason we don't use HTML is because we want to avoid that as often as possible. We're almost getting to the point where we actually start learning something. There are three aspects to a web page. At least we're past the internet, the web. We're down to actually web pages now. When we're dealing with web pages, we've got three things. We've got structure, we've got style, and we've got behavior. What is structure? Structure is content, basically. It's described content. So content, you've all been to web pages, that content might be a description. It might be a product description, for example. This is our new car. This is the information you're going to learn about it. This is your structure. And XHTML also allows, or in your structure, you can define information, which is what's really cool about a lot of web technologies. You are able to say, this is my structure, this is the content, and this is what it's used for. It's all self-describing in the document. We'll show how that works in a little bit. But that's what makes the structure of the web. But there's nothing in the structure to make design. When we talk about website design, you're not talking about putting a bunch of text that's just, white background, black text, and here it is. That's not what we mean. We want to see something that's interesting, that looks attractive, that interacts with us. There's actually a separate language, a completely separate technology for doing that design without any content whatsoever. No text, no descriptions, no this is what this is. It's just design all by itself. And that language is CSS, or the Cascading Style Sheets. This was actually introduced in 1996 or 7, so it's actually been around quite some time, but its use took a long time to really come into play because HTML wasn't designed to work with it. And the last thing is behavior. And behavior is a really complex topic, and we're not going to be discussing it in this class other than what it is, where you might want to use it, because you really get into, we would have to offer a lot more than 12 hours to talk about behavior. And a lot of websites don't have behavior. Most of their behavior is static. My behavior is to sit here, and that's what websites do. They sit there, and you look at them. You can scroll up and down, but they don't do anything. But if you want to get into using the technologies of ECMAScript and the document object model, you can make websites that really do things. You can make websites that move. You can make websites that interact with the end user. You could, in theory, make a video game on a web page. It actually does stuff, but this is a lot of work. This is not things that you do with standard web technologies. And all of that will be done in ECMAScript because it's the power to automate a web page. So those three things are the aspects of web pages, and we're going to be dealing with the first two. Okay, when we're making a web page, what we're talking about is really a file. There's nothing really magical about a web page. If you've worked with K-Office, you've worked with K-Word, you've worked with K-Spread, you write up a document, you save it. What do you have? You have a file with KWD as the extension. That file is all the data you're dealing with, and K-Word is the application that opens it. We're all used to that metaphor. We're used to applications and the files they work with. Well, on the web, what we're really dealing with is an application called the web browser, Internet Explorer, Conqueror, whatever you're working with, and the files just happen to have the extension .html. That's it. That's all there is to know about how it works. Does anybody have any questions about that? How it really is. You can put it on your local computer. Your computer's sitting out here. You can have a HTML document. You can have your browser. You can open it with the browser. You don't have to have the internet there. You don't have to have the web there. You don't have to have a server. You don't have to be online. You can just have a file and an application that opens it. So you can read it just like Word. Okay, everybody's okay. Not sure if everybody's asleep or...
I got a question.
Yes.
So what we're going to be doing is we're going to be typing documents that now are .html instead of what is it, SMX now?
Yeah, there's
Yeah. So that's what we're doing?
Yes.
Okay.
You are making a text document that just happens to end in .html,
Okay.
and that's what gives us the ability to make web pages.
Okay.
And that's what this says. Okay. I had nowhere to put this part of the presentation, so in order to set up an actual website, if you're going to host this and not just make a page on your own computer, you have to register a domain name. Go get mycoolwebpage.com or whatever. And then you have to either have a server that you run, which is an option, or you have to go find someone who has a server that's going to run one for you. Getting a hosted server is not expensive. You're probably looking at about $10 a month for a lot of services for small web pages. It's not a lot of money. I mean, $120 a year is $120 a year, but it's about $35 a year to own a domain name, and about $120 a year to run a small website. Those are the things you have to have. Other than that, all you need is a group of web pages of these files that you design yourself and you give to that server or you put on your own server. Okay, in order to make web pages, there's two groups of tools you can use. We can use, on the left, what are called WYSIWYG editors. These are graphic editors. They're more like Word. When you work with Word, you format all your text on the screen, you just highlight it, you make it bold or italics and change the color, all that, just like a word processor. These four products, Dreamweaver, EnView, FrontPage, and GoLive, are designed to work like that. They're meant for you to use them roughly like a word processor. And EnView is new and it's free. And so it's definitely worth taking a look at the end of the class. Dreamweaver is the industry standard. If you're going to be a professional web developer, you're going to work with Dreamweaver, and that's the way it's going to be. This product is about $400 for the base product. You can get advanced versions of it at the top of $1,000. But it's a really nice product. GoLive from Adobe is the only other acceptable professional option. Probably about 5% of professionals use GoLive. About 94% use Dreamweaver. EnView hopefully is going to be taking some of that ground away, but it's really new. It doesn't have very many users yet. FrontPage does the same kind of work, but it is specifically designed, and this has actually been a lawsuit, and it's actually been admitted by Microsoft, that the purpose of FrontPage is to create websites that only work in Internet Explorer. It specifically creates websites that other browsers can't read. So it doesn't produce XHTML because the web browsers we use read XHTML. It produces something else. It doesn't produce CSS because the web browsers we use CSS. It produces something else. It does produce web pages, and it does produce nice ones, but only a much smaller percentage of your potential audience could possibly open them, and no one here at the school could because we don't have Internet Explorer. But these are the big graphical tools. The reason we're not going to be using them in this class, one, we don't have $400 per student. The other is that they don't really teach you a lot. The purpose of those tools really comes into play once you understand how to make web pages and you want to make some of that process easier. Well, I want to make it look a certain way. Well, you can do a lot of that fiddling around with these tools really easily. You don't have to spend a lot of time doing really hard work because of it. And once you know how to use web technologies really well, Dreamweaver, GoLive, these tools will let you do whatever you need to do. They're not going to hold you back in any way, but in a learning environment, they're going to make it really, really difficult to move forward. You're going to be caught up in things that are not helping you learn. On the right, what we have is a group of editors that are designed for exactly what we're doing, making web pages using the underlying technology. BB Edit is for Mac, and it does cost, I think, about $50, so I don't suggest it. The other three are free. HTML Kit on Windows, really great product, that's what I use. Quantra and Bluefish are for Linux and the Unix operating systems. I'm sure you can get them on Mac, I just don't know how you have to go about doing it. But they're all free. And what they do is, they do things like colorizing, which makes it easier to code. They have online references and stuff right there with you. But they're not really big, complicated applications. Mostly when you're working with everything we're going to be doing in this class, you can feel free to do in Notepad. If you're on Windows, on the machines here, there's a program called Kate, and the instructions are on the papers that you got on how to fire that up. But all the machines have Kate on it, and it really is just Notepad for Linux. And that's really all you need. But if you're going to do any amount more than this class, if you're ever going to make your own page, if you're going to work on anything, you're going to want something like the HTML kit or Bluefish or something, just because it really does make web design a little bit easier, because it just makes it easier to read, easier to understand what you're doing. It's going to help point you in the right direction, but it's not going to take away from your need to know how it works. And many professionals will use something like Dreamweaver, get a really rough draft done, and then bring it over to something like Bluefish or HTML kit, and then they will do it by hand once they have the bulk of it out of the way. Do you have a question? Yeah.
Yes, I do. How would you get to, I don't know how to pronounce NVU?
NewView? NView?
Yeah. How could I go online and?
NView.org.
Okay.
Yep. I haven't played with it too much.
I'm sorry.
Dreamweaver is at macromedia.com.
I know.
Go Live is at adobe.com. Front page, obviously, Microsoft.com. It comes with some of the Microsoft Office packages. I'm not sure which ones. HTML kit is at chami.com, chami.com. Bluefish and Quantra, I don't know off the top of my head, but you can do searches on them pretty easily. Bluefish, HTML, it'll come up.
Okay.
So what is a website? A website is simply a collection of web pages that are kept in one place. That's all there is to it. You make a group of web pages, you have a website. Generally, when you go to a website, there's going to be one of those pages that is the default page. It's the page that if you don't specify which specific page you want to look at, you're going to see that one. If you go to yahoo.com, we'll keep clicking on Yahoo. You don't type in the actual page that you're going to. You just type in Yahoo, www.yahoo.com, and Yahoo says, well, they didn't specify where they want to go. They must want this page. And it's generally a page that makes sense. It takes you to all the other pages. When you're making your own websites, think about this. This is where people are going to go. They're not going to type in. It's very rarely that someone will type in the actual name of this page they want to go to. They're going to type in the name of your server, www.boythisiscool.com. And whatever page you designate as the default page, that's what they're probably going to see 99% of the time. Okay. We've discussed XHTML as a markup language, but what is a markup language? What are we talking about? Well, everyone's familiar with the idea of teachers marking up papers. You write a paper, the teacher whips out the red pen, and this is awful, and this doesn't make any sense, and this needs changed. What is the teacher doing? The teacher's marking up that document. And you all understand what it is because the markup makes it obvious. Well, a markup language, XHTML, is a language that does the same thing for text. It is a way of marking it up. All the information that you want to tell about a document is in the markup. You can tell things like, oh, this group of information right here, this is a paragraph. And suddenly it's not just a bunch of text on a page. The document knows this is a paragraph because you marked it up. And you can say, this part's a table. It's going to be like a spreadsheet. And you can tell it that. And it says, oh, so it's a table. Now we know. So markup languages are really a really simple concept that's used to define parts of a document. And you're used to working with some really common markup languages. OpenOffice writes its documents in a markup language. You don't ever see that markup language, but that's what it uses underneath. KOffice, that's what it uses. Microsoft Office, same thing. I had some other good ones that I thought of. Almost all those types of products, they use markup languages, normally ones they made up themselves, to define their documents. So the question is, what is the difference between a markup language and a programming language? A lot of people like to refer to writing markup as programming. The reality is marking up and programming are two separate things. Marking up is a way of designing a page. You can design how it looks, you can design what different parts of the page do. Programming would be analogous to a recipe. If you're going to be cooking, when you get a recipe, what does a recipe do? It doesn't tell you about the ingredients. You know what the ingredients are. If you don't, you should go look it up. But the ingredients are just part of the information. The real thing in a recipe is a set of instructions. It tells you what to do with the ingredients. It tells you when to do it. It tells you how hot to make it. It tells you what steps to do. It tells you how long to wait between things. The thing that makes a recipe is that it is programmatic. It is a set of instructions that take you from one thing to another. So when you're programming, what happens is you're giving the computer instructions. But when you're marking up, you're not giving instructions. You don't tell the computer what to do. At no point are you instructing anything. What you're doing is you're simply describing things. So it's a little bit of a different practice. If you're going to be programming, if you're going to be making programmatic code, you're called a programmer. If you're going to be making markup, you're called a designer. Does anybody have any questions about the differences there?
Yes, could
Yeah.
you go back to that last page, just one more second?
Yes.
Produces programming code as well. Okay, thank you.
Okay, so how do we mark up a document? What does this mean? Well, we use a lot of markup languages, not 100%, but all the ones we're going to be dealing with use a system called tags. And tags are great because they're so simple. First time you use one, you'll be like, wow, this is the easiest thing. What a tag is actually, this is a good example of a tag. We have, in this case, we're using brackets to designate what a tag is. The tag is this section, opening bracket, the name of what the tag is, and the closing bracket. The information that you are marking up is the information that comes after the tag. And then we have a closing tag, which is designated by being the same word as the opening tag with a slash in front of it, inside brackets. Does that make sense to everybody? What I'm talking about with tags? No? If you had just pure text, you would have these words, stuffing tag. Okay, but it's not in a tag, it's just the word stuffing tag. And you say, I want to tell this document that these words are something, that they're not just text floating out in the universe. They need to have a purpose. We need to identify them. And so in this case, I want to identify them as a tag example, so I use the tag called tag. Tag's not a real tag. You don't really use a tag called tag. This is just an example tag. It wouldn't be useful to say, this is a tag. I guess if you're going to do this, you would say tag, 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 because the tags, we're saying the tag is a tag. I should have used a different example. I should have said words. Imagine these words tag say words. I'll change this, so next time we do this, we have words, stuff in tag words. So now that these tags are here, the stuff in between it is tagged. It is marked up.
So on the web page,
Mhm.
you would only see stuff in tag, but then
That's
you would not see tag. But in order to design it, you have to tell it tag, tag. I mean, tag at the beginning, tag at the end.
Right. Well, for example, when we first start working with a web document, everything that is part of the document needs to be within a tag. There's an HTML tag that says document is starting, and another one at the very end that says the document is ending. And only the stuff in between is, because you can put notes at the end.
It's like parentheses.
Roughly, yes.
Okay.
Yep. One of the things that's important to know about XHTML, first of all, like we said, everything must be in a tag. Absolutely everything. Tags must be open and closed. This is something that seems really obvious the first time you're learning about web design, but if you've used web design in the past, if you used old HTML, they had some really sloppy things where you didn't have to open and close tags. You could just have a tag saying this is the beginning of a something, and you would hope that the browser would figure out where the end was, but you wouldn't tell it, so it was guessing. And that's kind of rough, because there's a lot of ambiguity there. You could have the end be just about anywhere. Tags are always lowercase. Do not capitalize. This is important. New compliant browsers will not display anything with a capitalized tag. Tags can have attributes. I'm not going to go into too much detail about this right now, but you can identify text as being within a tag, but you can also have a little bit of additional information about that specific text. And that's what, this example here is just a plain tag. This one is a tag with an attribute that in this case is info about tag, and then the same closing tag at the end. We will see towards the end of today's lesson where you would actually start using that. But it allows you to be more specific, so you're not stuck with 5 tags and that's all you can say about a document, or all kinds of information in the attributes. To make markup work, since we have to open with a tag and close with a tag at the very end, obviously we're able to hold all kinds of other tags within those tags. Tags can be nested. They can all be inside of each other. So this is, it's additive. You can say, this is the beginning of a paragraph, and then you can say, this part of the paragraph is italic. And then you can say, now we're back to the regular part of the paragraph, and then the paragraph ends. So you can have all that in one spot. This is new with XHTML, and this is really tough when you haven't done it before. Tags must be opened and closed in a last opened or first in, last out order, which is also last in, first out order. So if you open 20 tags, you can just open tag after tag after tag after tag. You don't have to have anything in them. And then you put something in it, and you want to start closing tags, you must close the very last tag you specified. It'll be better when we see an example. But it's something you have to be real conscious of, because it's really easy to have tags overlapping in weird ways, and the system will not allow you to do that. That is called properly nesting. It's just the term for it. The other big thing about XHTML is white space is irrelevant. What is white space? Anybody have an idea what white space is?
Paper.
Paper is white space. Yes.
White space would be where you have XHTML is not A, and then you have a bunch of spaces before it says language used for design. Those spaces are white space, right? Unless you
Right.
define them as spaces.
Something else.
Yeah.
In XHTML, what is a white space? Is a single space, like between the word era and of. There's only one space there. That's not white space. It's actually a space, because it needs a way to know that one word ended and something else is coming later. What's white space is the second space after it. If you hit spacebar twice, the first space is a delimiter saying this is the end of the word. The next space is just nothing. You can put 2 spaces, 3 spaces. A carriage return, you can go on to the next line. You can go on to 20 lines later and halfway across the page and keep going, and as far as it's concerned, 1 space has occurred. Because it doesn't know anything about white space. And the reason that we use that is because it allows you to format your markup in any way you want. You can have some style where every word is on its own line, just because it's easier for you to read for some reason. You can cram everything, you can cram every word in the entire document onto one line that goes on for a mile. If you think that's easier to use, it doesn't matter. It allows you to do what you want. The only thing you have to worry about is putting 1 space between words, because obviously it doesn't know where the words start and end. Okay. We talked about this a little bit. Structure, not design. XHTML is a language of structure. It is not a language of design. So what we use is we use the markup in XHTML to define what parts of that document are. We tell it this is a paragraph. We tell it this is a table, and that's what that's the structure. Because obviously that's not design. It's just this is a paragraph. It's actually telling nothing more than the fact that something is a paragraph. If you were writing an essay, instead of indenting and skipping a space between paragraphs, if you could just say, this is a paragraph, and let your teacher figure out how they wanted it formatted, it would be that much easier, and that's what's happening here. Back in the HTML era, up till 1999, they actually tried putting design in the same language as the structure, and it became really sloppy and really difficult to manage. That's why they moved away from it. One of the reasons standards is really important, and one of the reasons the structure is incredibly important, is because browsers view the same structure in different ways. It's not really important to you how a browser is going to show a paragraph. It's only important to you that you say it's a paragraph. The browser will decide whether it's going to indent it, whether it's going to space it in a certain way. That's up to the browser. It's important to realize that an end user, a client, has the ability to tell its browser to do things that you haven't told it to do. They can make it that paragraphs are in blue. Anything that's paragraph is blue. You were thinking that it would be indented like a regular paragraph, but no, they said, don't indent, just make it blue. And you may not be prepared for that. Because XHTML is structured, they can make up their own behavior for what those things are going to do. And also, this is really big. Why structure is important? Because not everything's a browser that's going to read your web page. Your web page could be read by a screen reader, which is actually a device that goes through and reads the words out loud for people who are blind. Your web page could be translated so it goes onto a braille pad, also for people who are blind. People who are deaf don't often need anything special for a web page, because if there's audio, they don't normally need it. So there isn't anything special for them. But there's a whole bunch of structure specifically designated in XHTML so that these types of accessibility devices will work with standard web pages. All right, we're up to actually what parts of a web page, but we have only 5 minutes left, I believe.
10.
10? Okay. There are 3 main parts to any XHTML page.
Make sure you show tags or you're going to lose them.
We're going to see tags in a second.
Okay.
The very first part, and the XML declaration, this is actually wrong. It's actually an XML definition. This is boilerplate. This isn't something that you need to know why it works. If you're going to get into advanced web design, definitely there's lots of reasons why you need to know it. But starting off, you're going to take what's given to you in this, you're going to copy it, and you're going to put it at the top of every document you make, and that's it. Never have to worry about it again. Just remember to put it there. Life goes on. I realize that's confusing at this point, but there's a certain amount you just have to do like that and learn about it later, because this part would be really complicated if you knew what it did. This is your XML definition. Yep, isn't that exciting?
Sure is.
You don't need to know anything about this whatsoever. This is in the slide. It's in all the books. You can find it just about anywhere. Everyone uses almost exactly the same thing. This one is specifically designed for the stuff I'm teaching you in the class, so get this one from the slide and you're good to go. Don't try to write it down because it's character specific. It's really, really needs accuracy, so copying it directly is the way to do it. That's it. Let's move on. Okay. The head section of XHTML. This is the section that holds important information about the document. This is where the document talks about itself. And the really, really big thing that goes in here is the title. And really it's the only part that we're going to worry about, at least for quite some time. And the title is required for the spec. So you always have to have a title just so your web page has a title. It's that simple. A lot of different accessibility devices need to know what the page is called. You can eventually use meta information in the head section, and what this does is you can, for example, you can have a set of keywords. This is what the page is about. This is the subject matter. You know, this I like kittens. You can put that in a meta tag, so people can be like, "What's this page about?" Oh, it's about people who like kittens. All right. This is a sample head section. Woohoo! That's all there is. We were talking about tags. These are real tags, and these are ones you'll really use. HTML is the tag that opens a document. This comes after the XML definition, because the XML definition is actually not part of the XHTML document. The HTML opens it, and then we start the head section. So we need a tag to say this is the beginning of the head section, and that tag is head. Boy, that's easy. Now we need a title, because we have to have a title. So luckily the tag for this is called title. This is really easy to remember. That anything you put after the title tag is your title. You can name it anything you want. This is completely up to you. The wonder of web design. When you're done coming up with your title, all you have to do is use a closing title tag, which is the title, word title again, with the slash in front of it. And then, as long as you're not going to do anything else in your head section, and since you can only have one title, we might as well be done. We're going to close with a closing head tag, which is head with the slash in front of it. Is everybody okay now with how the tags are working?
Mm-hmm.
And the reason we don't have a closing HTML is because we still have the body section left to go. So that's going to close after the body. All right. The body, obviously, we don't really have to talk about very much because everything you're going to do in a web page is in the body. The head has the title. Woohoo! Okay, but the body's where it's exciting. This body, however, is not exciting. You are not required to have anything in the body of a web page. You are required to have a title, but the body can be blank. In this case, we have a blank body. The body opens, the body closes, and then the web page closes. HTML ends. That's it. Woohoo! Now, if we want to start adding anything to this body, we have to use, obviously, another tag. You can't just put text loose in the body. It has to be in some sort of structure. The 3 really big pieces of structure that we're going to use for putting text on is paragraphs, because almost all text goes in a paragraph. We're going to use division, because sometimes you need something that isn't a paragraph, and division kind of gives us the flexibility to use non-paragraph text. And headings, because titles on things are really common, so they made a special category just for that. so that any given paragraph or groups of paragraph can have their own heading announcing what it's going to be. And we're going to be taking a short break in just a few minutes. The reason that there's 6 of these H1, H2, H3, H4, H5, H6, there are 6 different heading tags. They're not particularly exciting, and most people only use about 4 of them. But what they are is H1 is a first level heading, H6 is a 6th level heading, and everything else falls in between. And what that means is H1 is typically used. We're pretty close there. Typically, the H1 heading is the largest heading. It's going to be the biggest, boldest words on the page, or at least the browser knows that's what you're thinking. H2 is the next one. It's not as big and bold as that, a little bit less. H3 is a little bit less than that, and so on. It's so that if you're writing a paper, you can put H1 in. Maybe that's the title of your paper. But then H2 is your chapter headings, and H3 is subject headings. Good question.
So it's kind of like the letter size.
It's roughly the letter size. In a regular browser, it will be letter size, but it doesn't have to be. It could be how bright it is. It could be how loud it is on a screen reader. Some screen reader could shout it because it's an H1 and whisper it because it's an H6. And in case no one figured this out, P is the paragraph tag, and div is the division tag. These are what we're going to be used for almost everything we put on the page. And if there's no more questions, we're going to wrap up for this first half and take a short break. We're going to change tapes. People can go to the bathroom, get a drink of water, whatever, and then we'll actually start seeing actual web pages and samples. Okay?
And they are just as delicious as I remember.
Thought you weren't eating those.
That was yesterday. Today I'm eating whatever I want. And what I want right now is one of these.
So what? You've just given up? You can let the time bomb explode?